Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem sum of dependencies in a graph. This is an easy level question and the company tags of this question are Flipkart, and this is the problem of the day on Geeks4Geeks. Alright, so let us go through the question. Given a directed graph with V nodes and E edges, if there is an edge from U to V, then we will say that U depends on V. Okay, this is a directed graph. So if there is an edge from U to V, that means U is depending on the V. So that is what the definition of dependency is. So number of dependency for a node X is the total count of nodes that X depends on. Okay, so find out the sum of the number of dependencies of every node. So that means node in the sense vertices. So let us assume there are V number of vertices. So for each of them there will be some number of dependencies. So we just need to add them up. So it's pretty evident. Okay, so these are the examples that have been given. So we'll see that, and the expected time complexity is O of V. That's expected because we just need to deal with V vertices, and that's so is the reason it's O of V, and auxiliary space O of 1. Yes, we need not use any extra space to deal this. We will see that now. So, and the constraints are number of vertices can go up to 10 power 5, and same as this case, like edges can go up to 10 power 5. And yes, so what about the driver code? It's important to see the driver code. So driver code is like this. So vector int v of n. So it's like basically you're making a directed graph in such a manner, like you're making your adjacency list in such a manner that each of the vertex or each of the node will be the index of that particular vector, and every index will be having a particular vector associated with it, which has all the nodes it is connected to. All right, so if I put that in layman terms, in simple terms, let us see this example. You'll be getting an extra clarity. So here the edges are like this. Like what are the nodes first? Let us list out the nodes first. 0 1 2 3, isn't it? Because v is equal to 4, so the nodes start from 0 to v minus 1, that is 3. So if I'm actually required to construct that particular vector, so if you see from the edges, 0 is actually having a edge with 2, it's having an edge with 3, so 1 is having an edge with 3, and 2 is having an edge with 3, isn't it? So in the same way, the vector is like this. So at 0th index there is a vector of size 2, okay, and at first index there is a vector of size 1, and at second index there is a vector of size 1 again, and at index 3 there is nothing, there is a null vector, there is a 0 size vector, because 3 is not depending on any of the like the other vertices. There is no available vertices after 3. Everything has been used. 0 1 2 have been used, right? And from 3 there is no other vertex through which there is an edge. Like from 3 there is no other edge. Okay, this is a directed graph, please remember that. So from 3 there is no edge, so that is the reason 3 corresponding vertex, like at index 3 vertex is like index 3 vector is null vector, so there is nothing, like it's a 0 size vector. And at index 0, the vector associated at index 0 has size 2, because at 0 is having an edge to 2, 0 is having an edge with 3, right? 0 is from 0, 2 is connected, from 0, 3 is connected. So that's the reason there are 2 elements in the vector that is associated at the index 0. And for 1 there is an edge from 1 to 3. So that is the reason there is a vector of size 1 that is associated at index 1. And from 2 there is an edge to 3. So that is the reason there is a vector of size 1 associated at index 2. So that's it. So what can we understand from this? So for 0, what are the number of dependencies? 2, because there are 2 edges from 0. For 1 there is only 1, for 2 there is only 1, for 3 there is 0, right? So it's just that you add the vector size corresponding to that particular index. Okay, so you just need to add the vector size corresponding to the particular index to some sum. So if I assume int sum equal to 0, so then I'll be going through all the indexes, that is 0 1 1 2 3, and I'll be adding the corresponding vector sizes to my answer, and finally I'll be returning it, isn't it? So that's it, pretty simple. So let us code it now. Initially take a sum variable like int sum equal to 0. Now traverse all the vertices. So int I equal to 0 starting vertex till the vertex, like int v. So v stands for, like if v equal to 4, what are the vertices that you'll be visiting? 0 1 2 3. Okay, so and then I plus plus. Now add the corresponding vector at that particular index. So adjoint of I dot size. Okay, add adjoint of size of the corresponding vector at that particular index. Okay, and then finally return sum. So this gives me the total number of dependents according to the question. So if we just check it before submitting, so that should give me a correct answer. So yes, it is giving me correct answer, and then we'll submit it. So yes, it worked. So I hope you people understood. So for your reference, codes in Java, Python, and C++ are there in the description. Please go through them. So it's pretty evident, pretty simple question. It's just that we are seeing the adjoint vector, like how it's being there, and just adding the corresponding vector sizes to our sum variable. That's it. Nothing else we are doing. So thank you for watching, guys. Stay tuned.